Greetings everyone, my name is Mark. I am a high school student and I am aspiring to become a quant. I'm very passionate about math and finance, and I'm recording these videos because if I'll ever get stuck, I'll just come back to them, and I'm mostly recording them so that I'll um, gain a or have a better understanding of math and finance, because if you explain something, you remember about 90% of the things that you say, whereas if you only read your notes or go through your textbook, you remember only about 5% of the things that you read. So that's why I'm doing this, and since that I'm already recording this, I might as well upload this somewhere and someone might find it useful. I plan on covering multiple topics from simple mathematics to complicated quantitative methods, and today I'll be looking at or will be looking at, or doesn't really matter, I guess, at number sets. And now there's hundreds of ways how people, you know, write down number sets and whatever they do. And some people have more sets, some people have less, some people, have a different notation. Instead of for example, I, some people, for the irrational numbers, people use P, for example, um, or, you know, uh, and then they use I for the imaginary numbers, for example, right? So there's a thousand ways how to, for the notation, all that stuff, but this is how I'm used to doing it. This is how I like doing it, and I think this is very clear. So first of all, we have the natural numbers, where all the natural numbers are numbers without a decimal point, which are greater than 0. 0 is not included. So those are all of your numbers 1, 2, 3, 4, and essentially the natural numbers only contain one number, and that is basically 1, and um, all of the sums of 1 repeating. So that can be 1 plus 1, 1 plus 1 plus 1, 1 plus 1 plus 1 plus 1. So it's essentially the number 1 repeated by, by repeated addition. Then we have the so-called integers. These are all of the natural numbers and 0, and all of the negative numbers without a decimal point, obviously. So yeah, so those are the integers. Some people like drawing here another set for the whole numbers, and that's for the natural numbers and 0. And that's so you get natural, whole, and integers, but I'm not really used to doing that. I'm just saying it just so that you guys know that some people do that and that it exists, but I don't really think it's that important. So the natural numbers and integers will do. And then we have the rational numbers, and the notation for the rational numbers is the letter Q. And these are the numbers which you can write in as a fraction or in a certain ratio, where the number in the numerator needs to belong to the set of the integers, and the denominator needs to belong to the set of the natural numbers. So essentially, the natural numbers and the integers both belong to the set of rational numbers. So those are all of your numbers, like, for example, 1 over 2, or 1 over 1, which is equal to 1, essentially, or negative 3 over 8. Essentially every number which you can write into a fraction where the numerator belongs to the set of z, or to the set of integers, and where the denominator belongs to the set of n, or the natural numbers. Then we have the irrational numbers. And now the irrational numbers are rather interesting because you cannot write them in a, numerically define them as a ratio or as a fraction. These are numbers that have interesting properties. For example, the number pi, or the square root of 2, or the logarithm with the base of 2 and with 5, or the logarithm of 5. Sorry, the logarithm of 5 with the base of 2. Yeah, so those are the irrational numbers. And then we have the real numbers. right here. I'm not sure why there's pi right there. However, that's not wrong. Pi does belong to the set of real numbers. And essentially, the real numbers are made up of the set of irrational numbers and rational numbers and irrational numbers. And it's very important to realize that the irrational numbers belong to the set of real numbers and not to our giga set, or this large set, the rational numbers over here. So those are two different sets essentially. And when you combine both of these sets, you get the set of the real numbers, which are essentially most of the numbers which most of you guys will study. We then have the imaginary numbers. And now the imaginary numbers are, you might guess from the name, numbers which we can't essentially numerically that do not have a numerical notation, in a sense that we can directly pinpoint where the number is on the number line. And for example, some imaginary numbers are, for example, the square root of any negative number, negative I, 3i, and where I is the square root of negative 1. So these are the numbers which we can define with an exact number. And then we have the set of complex numbers, which are essentially numbers made up of two sets, if you will. For example, 8 plus 2i, or 7 minus I, where 8 is the real part of the complex number and 2i is the imaginary part of the complex number. And both the real numbers and imaginary numbers belong to the complex numbers, obviously, since that we have the real part of a complex number and the imaginary part of a complex number. This is a quick notation on how to have it simplified, if you will. This and this is essentially the same, where n belongs to z and z belongs to q and q belongs to r and r belongs to c, where n are the natural numbers, z are the integers, q are the rational numbers, r are the real numbers, and c are the complex numbers. It's also important to know that, just like on the picture on the slide before, right over here, that the imaginary numbers belong to C, or the imaginary numbers belong to the complex numbers, and that R is made up of the rational numbers and the irrational numbers, just like so. Not the exact sum, but take this as sets. That's what the real numbers are made of. Those are the sets that it contains, and the rest is history. That's all I have prepared for today. Thank you very much for watching. Stay safe and take care.